All right.
Well, hello everybody. Thank you guys for coming to our third fight session of the quarter, I believe. We're trying to do them every single week on Thursday. So if you like this one, come to the next one, and the next one, the next one. Just a little bit of business before we start. Hacker Factor, the club that hosts and runs these fight sessions, is doing our yearly elections, and we need as many people as possible to participate, either by running or voting. Help us keep this thing going when Keem leaves. I'm gonna need some help. So with that out of the way, welcome Beej. He's here to talk to us about object-oriented programming and text adventures, or so I hear. Pretty excited. Let's give him a hand.
Thank you. I'll take the applause in advance. That's good, because I don't know how well this is all going to turn out because of the time constraint. So we'll see what happens. And don't say that, because we could do this for like 3 or 4 hours without a problem. But yeah, what do I want to talk about today? I want to talk about object-oriented programming and text adventure games, which are, well, one of them is one of my favorite things. Object-oriented programming, it's all right. But I want to talk about what it is and how it works, and I want to talk about how we can use it to maybe put together a text adventure game. And what I'm after is going to be something that's web-based, that looks like this, and we should be able to type stuff like go west or go south and have it work. Right now it doesn't do anything because it's just a skeleton of all this, but hopefully we can turn that into something that's functional. But first, anybody ever play any text adventure games? 2 people or 3 people? All right. Yeah. So the gist of it is, back in the day when graphics cards weren't a thing, people are like, how can we make fun games? And so we'll just do it all in text, and we'll describe what it is you're seeing, and you can interact with the world by saying, like, take sword or drop sword or whatever, or go west or go south, and you'd explore this virtual text world in this way. And it turns out this is kind of a neat way to also model objects. Games in general are great for object-oriented programming because games tend to be full of objects. And so it's a great place to start, and I get to talk about text adventures for fun anyway. So object-oriented programming. How many of you have done stuff with object-oriented programming? Most of you. So we're stepping into it a little bit ahead of the game, which is good. So the whole idea with object-oriented programming, it's a programming paradigm, which I like to describe as a way of modeling solutions to problems. So we have some problem that needs to be solved because somebody's paying you money to solve it or whatever. We need to somehow take that description of that problem and turn that into a workable solution. And there are different ways of doing this. One of them is more procedural, like you might follow a recipe if you're making something. The recipe is like, do this, then do this, then do this. It's not really modeling anything. But that's how we write an awful lot of C code as well. If you write in the C programming language, we write a lot of it like that. Functional programming tends to model things as a bunch of functions that are related to each other. Object-oriented programming, we model the solution as a bunch of objects. And objects have properties, and they have actions that they can take, how they respond to different inputs, and so on. So this is a way of solving problems. Solving programming problems. And I'm going to add right here that for me, learning new programming languages isn't the hard thing. The hard thing is learning new programming paradigms, learning new ways of solving problems. And I think it's also one of the best things you can do as a software developer is learn a programming paradigm you don't understand, like learn functional programming. An example I brought up in class before is the Erlang programming language. It has a great feature where all variables are constants. You can assign to a variable, and then you can never change it. And I was like, all the ways I know of solving problems involve changing variables. So how do you solve any problems? Well, it's just a different way of approaching solving problems. So I learned that paradigm, which was a very painful experience, but afterwards I was able to bring that knowledge to bear in other circumstances. So it's hard, but worth it, I think. So with our text adventure game, well, actually I'll get to that in a second. You all have done programming with object-oriented programming, so I'm going to be kind of brief with this, but classes and objects. Classes are like the blueprint for objects. You can use a class to make a bunch of objects, and objects are the blueprint brought to life. So just like with houses, somebody has a blueprint somewhere of the house that describes the structure, and from that we can cookie cutter a zillion houses of that same design. And we can do the same thing with object-oriented programming. The class is like the blueprint, and the objects are what we make from that class. And a lot of games use this to great effect, where you might have a whole bunch of a certain type of enemy running around the level. There's probably a class that's the blueprint for that kind of enemy, and then we've instantiated, they call it, made instances of that enemy all over the level. And we made them all from the same blueprint, and since the blueprint contains not only what they look like, but how they all behave the same way. So how can we come up with this stuff? My favorite way is to get a written description of the thing. So I want an adventure game where the player can walk around from, let me get my text wrapping on here, whoops. Walk around from room to room and can pick up objects like swords and drop them in other rooms. So here's my little start of my description. This is what I want to get. I could keep going, I want there to be creatures and treasures and stuff like that. But this is enough because I won't be able to code any more of that live in this session. So my favorite thing to do is when I have one of these, I run around and I identify the nouns in this thing. Not every noun is going to end up being an object in the game, but it can sure help lead the way. So I'm thinking I want to be able to pick up objects like swords, and so objects, swords, there are some nouns. I've got a player, I've got rooms, here are some more nouns, and a lot of these might be good things to blueprint. Like, I'm going to have a lot of rooms in the game, so maybe I could have a blueprint that represents a standard room, and then I could make a bunch of rooms from that. I'm going to have a sword in the game, but maybe that's too specific. Maybe I'm going to have just objects that we can pick up. So maybe there's a general blueprint for an object that we can pick up. And later on, we'll see that we can specialize these objects a little bit more to be different from one another. I also have a player that probably has some sort of attributes associated with them. So I'm looking through here, I'm thinking, how about the player and the rooms and objects to pick up? I'm going to call those entities because I don't want to use the word object here because this is object-oriented programming. So I'm going to call things that you can pick up entities instead. And so that's sort of what I have so far, and I can use this to help drive how I program this stuff. In 20 minutes, we got 20 minutes left. We're doing okay. Before I go on, is this making sense to everybody? Questions about it or anything? So far, so good. Well, this is the last bullet point, so how hard could it be? Let's look at what I had here. Where'd my web browser go? Oh, it is there. Yeah. I was like, it's dark like a terminal window. That's what I was thinking. So I've got this thing set up in advance. I'm going to share the GitHub repo with all this stuff in it if you're curious about how it works. But Basically, I've got two sections on this web page. One of them is a text input, and it responds when you hit return. The upper div up here just appends stuff to it, a copy of what I typed and the output from the game itself. So let's take a look at how this works, and maybe at first, let's think about the rooms. Because yeah, the player seems like the player would come first, but the player's got to be in a room before they can do anything, so maybe we'll just start with how we could define rooms and make that work. So let's look at the code. Is it here? It is here. I've got a bunch of files here already. And I'm going to look at my game.js. Is this big enough for the back, or should it be bigger? It's okay? All right, great. Thing is, it's now it's too small here for my faraway glasses, so don't get older. What's going on here? This is the main game loop right here, this run game loop, and I have an infinite loop here. I read a line from that input thing at the bottom, and there's more code behind all this somewhere you can dig into if you want to see how it works under the hood. If the line's empty, let's do nothing. Otherwise, let's print out what the command is. So we saw that. We saw the greater than sign followed by whatever command it was I typed. And I split that command into a bunch of words. And then I'm doing some magic here to actually handle whatever the user typed. This part of the game is the parser. And I'm going to write a really simple parser here. Real games, even back in the 80s, were able to understand things like pick up the green sword and put it on the table. You could like type in sentences like that and it would figure out what you were trying to do. I'm not going to do that. We're just going to make a really simple parser here that can do a few things. But to start, let's not even add anything. I'm going to add a command to look at the room you're in currently, but first let's actually define something. I'm going to make another file here called classes, and we're going to define that room class. And this is all JavaScript, but it's similar in other languages. So I'm going to make a class room right here, and this is the blueprint again. And let's give it a couple features. So thinking about the room, what's it going to need? Well, eventually it might have stuff in it, but for now, it's going to need at least a description. Like when I step into this room, I want to know maybe what the room name is and what it looks like. So I'm going to put those attributes in this class, but I'm going to put them in something called the constructor. S-T-R-U-C-T-R. We're there, right? So I'm declaring a function in here, and this function is going to be attached to every room object gets created. And this is a special function, the constructor function. This is what happens when we make a new room. So when I say, hey, I want to make a new room object from that blueprint, this function gets run. And so I can do some stuff in here to initialize this actual instance of the room that I'm creating from the blueprint. So what do I want to do? I want to give it a short description and a long description. Let's do that. Or maybe a name and a short and a description. So I'll pass these into the constructor when I make the room, and then I'm going to store them in here. And I'll do this in a way that I'll describe in just a second, but give me 1 second to add some more boilerplate. I need to import that thing because I'm using it, so I need to bring this script in that I just made called classes.js. You don't have to pay attention to this. And then once that's brought in here, I have to import it. Import room from classes.js. So now I can use this room that I've just made in this other file. Not really super important for the presentation, but super important for JavaScript. So let me make a new room. And this is how it happens. I make a new room and I give it the arguments to the constructor. And the constructor, I was going to give it a name and a description. So I'll give it a name. Outside the cave entrance. And then some wonderful literary description is going to go here. Like, you're standing outside the cave entrance.
Outside.
A cold draft emanates, am I spelling that right? From within. The entrance is to the south. Great. So I'm making a new room. It's got this description, that name. One thing I have to do with those, though, is store them in the room somehow. When I've made the room, I've got to somehow associate it with it. And I think this is one of the more confusing things about object-oriented programming. So I'm going to put these two lines here. What am I doing? This is a special keyword in JavaScript. In Python, it's self. In other languages, it's called other things. But we're making a new object, a new real object from this blueprint right now. And we need some way to refer to this new real object that's being made right now. And so here, this keyword is telling us that. You're making a new real object, and this refers to that object. And so now, on this object that's being made right now, I'm attaching these two pieces of description to it. Making sense? All right. Let's see if we can make something happen with it. For now, I'm going to do this. Oh, I can't call it location. I'm going to call it loc. Location's reserved for something in JavaScript, apparently, according to the syntax highlighter, and I don't know what. But I'm going to let this be our current location, where the player is right now. I don't have a player object, but just temporarily, let's say the player is currently in room 1. And now I can write a function like, let's call it this. I'll call it handle look. It'll make more sense in a minute. But this is what happens when the player tries to look around. And so if they look around, let's print out some stuff. Like maybe in bold, I'll print whatever location they're in, .name. Remember, the location refers to a room, and the room has a name. So I'm going to say location.name to get that, and we'll end that, and maybe let's put some paragraph breaks around this. And then another paragraph break, and let's print out the location description. Did I get all that right? And then right away, first thing, let's just call that. And what else? I need to save this. Is everything saved? Yes, it is. What errors are we possibly going to get? We'll find out in a second. None. All right. That's not how you spell emanates, is it? Emanates? Emanates? Is it an A? This is only going on the internet. I might as well get it spelled right. With an A? All right. I knew that was looking wrong. All right.
Also, the location is undefined.
Pull request. Wait, the location was undefined?
Location.name was showing undefined.
Was showing undefined. This name, how though? How, Nathan? How's it showing undefined? Great.
Missing a quote, that's usually what kills me.
Well, let's see, loc.name is undefined. That means, but the description is right. So first argument comes in there. Name, this.name. I'm generally confused by what's happening. $loc name. Uh, yeah, let's get a console log of room 1. And whoops, now we got nothing. Oh, import not found, room. Well, that might kind of explain it. All right, so I messed up my JavaScript import thing somewhere. Import, oh, this is what I forgot, sorry. Export. JavaScript modules. I've got to actually export the thing, otherwise it can't import the thing. What about now? Haha, success.
I love how chill you are with everybody watching you. That was nice.
I think it's just because that was like probably the 17 millionth mistake I've made programming, so I don't know, I got used to it after a while.
Like, I teach, this is nothing.
All right, so what do we have going on now? We've got that thing. I want to add a quick verb to the game so that we can actually say something here. So the way I have this set up is that I can add commands here and like L for look or look for look, and it'll call that function. So I have it set up down here where it splits the thing apart and looks at the 0th word, and if it matches one of the things, then it goes there. So if I set it up this way, I'm hoping that I should now be able to look, and it'll print it twice. Oh, because it's printing it every time. Yeah, I have it printing every time. Does that still work? I don't recognize that command. Yeah. So I don't want it to print every time. I'd just like it to print the first time we jump in here. So let's print it up there. There we go. There's something interesting here too with this line where I've set the player location equal to room 1. It's not a copy of the room. It's kind of strange to think about in some cases because with a lot of time with equal sign, you're making a copy of something, right? A equals 12, B equals A, you're making a copy of the 12 is kind of a way to think about it. But with objects in JavaScript and with everything at Python, it turns out, we're actually just making another reference. So room 1 refers to that one room we made. Loc also refers to that one room we made. We got two things referring to the same room. But what this means is that if I make myself another room, you're standing very, very inspired descriptions here. Better call it room 2. You're standing inside the cave entrance.
A warm draft emanating.
I was going to say soft light from the north. All right, so we'll connect it that way.
Dude, your tone is like spot on. I love this.
So now if I change my room, the location to room 2 at this point and reload, we should see that we're in room 2 instead of starting in room 1. Now all we really need to do is add a way to move between these two things if I want to do that. So I could start in room 1, and how can we connect them though? Well, location refers to room 1 or room 2. What I really want is inside each room ways to refer to other rooms within the room. So from room 1, I want a way to refer to room 2 south of me. And from room 2, I want a way to refer to room 1 north of me. And one way to do this is to just add more attributes to these rooms. So I could say, for instance, room 1.s2, we'll say for south 2, equals room 2. And room 2, n2, the north 2, equals room 1. JavaScript is kind of nice. I don't have to declare these in advance. You can just slap new attributes onto an object all you want. And if I try to access these without doing so, it'll tell me that it's undefined, which is kind of nice. So now if I want to actually go from room 1 to the south, I'll be able to look this up and see if I can go that way. So let's add that. I'm going to add a handle south, and I could make this more general, but I'm not going to. There's ways to remove some of the duplication in this code, but I don't want to bother with it here. So if I want to move south, I need to, first of all, check to see, can I go that way? Like, is that defined from this room? So let's find out if it is. I'm going to say if room 1 location dot s2. We'll just do it this way. JavaScript allows you to be truthy with stuff like this. So if it's defined, this will be truthy. It'll return true. Otherwise, it won't be. So if this is okay, then move that way. Otherwise, let's print something out like paragraph. You can't go that way. Okay, so the question then is, how do I actually move? Anybody know the answer off the top of their head? Looking at it?
Loc equals, and then the room you want to go to?
Yeah, and which room do I want to go to? Yeah, loc.south2. If you've ever programmed a linked list, we're doing the same thing as current equals current.next. Except now, instead of just having a linked list one direction, we could potentially have it a bunch of different directions.
Is it going to get mad if we don't have the last paragraph?
It doesn't, because HTML is all loosey-goosey about that stuff, and it will automatically close it, basically, when it hits the next thing that causes it to automatically close. All right, so handle south. Did I mess this up? Does it look right? Let's find out. The entrance to the south, I have no errors, great. South? Oh, nothing happens because I just go south. But what about look? Can I look now? Aha. I'm now inside the cave entrance. I shouldn't be able to go south from here though. And so that works, because inside the cave entrance, south goes nowhere. It would be nice when I actually went south if it would print out the new description of the place that I just got to. So let's throw that in really fast. So let's move to the place, and then we'll just call handle look. So it's as if I typed look afterwards automatically. We'll see this thing go, and whoops, south. All right, great. And then for quick completeness, let's, it's kind of annoying me that I can only go south and I can't go north anymore to get back to where I was. So let's really quickly throw that in there. I'm doing some cut and paste repeating of code here. There's definitely a way to not do that and to be cleverer about looking these up. But I'm just doing this quick here. So hopefully this gives us a north. If I do this too, oops. All right. We got some more verbs. Oh, I keep clicking for focus when it automatically gets it. South, north. All right, what a game. But at this point, it's relatively easy to add new rooms if we want. Just instantiate a new room, give it a description, use the north to, south to, and we could add west to and east to hook them all up. And then we've got a place we can walk around in. Whew. It's been half an hour. Can I push it?
It's been half an hour. You can push it.
Okay. Because the one other thing I wanted to talk about was adding an item to the game that we could pick up and drop somewhere. So if an item just exists in one room, then can we pick it up and drop it in some other room? And yeah, sure, we can do this. Let's jump over to my classes, and I'm going to export a new entity, which was the name I wanted to use for my things that I could pick up. And I'm going to give this an identifier and a name and a description. And hopefully it becomes a little bit clearer why I do this in a second. It's ID, this dot name is name, and this dot description is description. I'm going to have the identifier be the thing that you type when you want to pick the thing up. So this is going to be like its really short name. The name will be something that has an article attached to it, like a sword, and then the description will be the description of the thing. So I should be able to make a new entity here, like sword entity. A rusty sword. This sword has seen better days. A longer description of it. And maybe this would be what we see when we look around the room. We see a rusty sword, and if we looked at it in more detail, like if we examined it, maybe this would be what we saw. And if we want to pick it up, this is how I would identify it for picking it up. So I've made that, and I've instantiated a new one with new, but this doesn't get me anywhere. It's just like a sword that's out in space someplace. Like I need to somehow be able to put it in a room. The room's got to be able to hold stuff. And our room currently can't hold stuff. But we can change our blueprint so that it can hold stuff. And so I'm going to say this room.contents is an empty array. So this room has nothing in it. And I can add some more functions to this using parlance of object-oriented programming. They're called methods when they're functions that operate on this object. But I could have an add item to the room where I pass in an item, and then we can add that onto our contents array. And I can also have a remove item. And this is where I really wish I'd had my notes handy, because I can't remember what remove is in JavaScript off the top of my head. 1 second. Classes, let me check here we go, yeah. This was a little bit weird. So this gets me the index and the array, and then I have to splice it out of there, which is kind of weird. But I had this special case in here. So if I try to remove an item and it can't be found, I throw an exception. That should never happen. And this is the way in JavaScript you remove an item from an array. I had to look that up.
What?
Oh wait, split, sorry. I typed that out of muscle memory. Splice, that's going to be better. Yeah, so the way splice works is splice, if you give it 2 arguments, it behaves differently than otherwise. But if you give it 2 arguments, this is the number of items to delete out of the array at that index. Ugh. Splice is a weird one. The short of it is, I want to remove some item. And maybe I should call it item instead of I, because we're used to I being an index. In this case, it's not, though. Oops, and I said entity here, too, instead. Item.
removing an item from an array in JavaScript is complicated enough that you need to have, like, you need to throw errors if it doesn't work?
I don't need to, but I figure if I accidentally use this code in such a way that I'm like, hey, remove the sword from room 2, and room 2's like, I got nothing. My options are either silently forget about it or raise the alarm. So, because this would be like a game coding error, right? If I tried to remove some item that didn't exist, the game should be stopping me earlier than if it got to this point.
So this is just like habitual responsibility of a game developer.
Yeah.
Okay.
Yeah, I love using exceptions for things that should never happen. This is one of my favorite things. Like, if I'm coding along, I'm like, this probably should never happen, but I'm feeling too lazy to like write a real error handler and a real error message about it. I throw this in here. This way, if I'm coding later on, I'm like, whoops, that exception got thrown. I must have messed something up that I never expected to have happen. So, let's see. But now I have that for this, and I should be able to, if I want to put that in room 2, I should be able to say room 2.add item sword and put that in room 2. That doesn't get me anywhere yet still, because I'm not actually seeing the contents of room 2. But let's figure out where my errors are. Entity is not defined. Oh, did I not import it properly or something? I didn't. Let's import the thing. This was also the first time that I used, it's still not defined. Did I not export it? Did I not call it entity? Export class entity. What's my error? I don't see it. Was that really the only error that was coming through? Entity is not defined, game.js line 7. Oops. I'm doing something obviously wrong here, but I don't see what it is. Did I save this file? Is it being cached? It's spelled the same all over. I am bringing that in, right? Disable cache. Let's do that. Thanks. Oh, I'm like Control Shift, reload. I don't know why this would ever be enabled with the debugger open. But there we go. So at least it built. But I'm still not showing the thing. Now I have some pre-baked code here that I want to just bring in on the interest of time. Let's see. Where is it? Here it is. I would just want to print out what else is in the room. So normally I print out a room description that looks like this, but I would like to also print out this stuff. And I need to change this from my, what did I call this? ID and name. Also C name. So if in this current room there's something in there, let's print out that we also see that thing and go through it all. Right? No errors so far? All right. So now I see that that's there. So now I need to be able to pick this thing up or drop it. And this is where we're going to get to the last part of the object-oriented stuff I want to talk about. And then we can throw in some pre-baked code to see it go. But when I pick this thing up, if I say take sword, I want that to go into my inventory. Like I have an inventory as a player of all the stuff I'm carrying. And at this point, I feel like I've kind of outgrown this player location thing that I've been doing. I could also have inventory, make that an empty array here, but it would kind of be nicer because these are both player-oriented things if I had a player class here. And inside that player class, I could have a current location. Let's pass in a location as a starting thing. This dot location equals the location, and the inventory I'll just make as contents of the player. What does the player contain? Yeah. So now, instead of having a location, now I'm thinking, I can make it const player equals new player, starting off in room 1, please. And let's grab that out of here. And now every place I used location, though, this is kind of annoying. Now that we put it inside the player object, I need to go through to all the places that we use it and make sure that I'm saying player dot on the front of it all. There we go. And hopefully this works the same way. And now the player has a container associated with them that they can use to store stuff. South, north, south. All right. So now we have that player, the container associated with the player. And now I'm thinking, you know what else? Let's do this. You got to be able to add items to the player inventory and remove items from the player inventory, right? So I'll just copy that up from the room. But that's annoying. It's annoying that I just copied and pasted a whole bunch of code. What if I decide to change it in one place? I have to change it in both places? This is common functionality between these two things. The player has this functionality, and the rooms also have this functionality. And when you have common functionality between two classes, you could actually do a neat thing in object-oriented programming, subclassing. You could make what we call a base class. We'll call it a container, maybe. And you can take all this functionality about the contents. We can put that in here. We can grab all this stuff. We can put it in here. And we can take that out of the player. And then I can say the player extends container. And what we've done is we've taken this general purpose container and I've made a specialized version of it called player. The player has all that same functionality that the container has. It's inherited it, we say. And so the player actually is a container because the player has extended container. And in the same way, we can make the room extends container, and then we can forget about all this and take that all out. So now we have the common functionality extracted into this base class, and the subclasses that inherit from it get that functionality. Is that making sense? All right. So all that's left now is to be able to actually pick stuff up. And I'm going to paste that in the interest of time. And try to make sure that I've been coding it differently here, so I'll do a little bit of backporting. I changed from snake case to camel case for some strange reason. Handle take and get is often a common variant of that. So handle take. The way these handlers actually work, they've been taking no arguments up here, but really I've been passing in all the words, just in case they need them. And so here, when I do a take, the direct object's going to be the second word. So I have a loop here that looks through the contents of the location I'm in to see if it can find it. And if it can't, then prints out an error message. Otherwise, I've got to remove that item, except I called it remove item, right? I've got to, if I pick up the item from the room, I'm going to remove it from the room and add it to myself. Did I call them remove item and add item? I did. And then I'll print out a message that I took it. And likewise, if I can grab this one, we should be able to drop the item, which is just going to be the same thing in reverse. We look, except this time, instead of looking through the room to see if we can find it, we look through the player's inventory to see if we can find it. And if we can't find it, we print out an error message. You don't appear to be carrying that. If we can find it, I remove it from the player and I put it in the player's room. And that's that. Let's see if it works. How many cut and paste errors can I possibly have made there?
I bet 0.
Come on, 0. It doesn't look like 0. Let's see. Oh, must call super. I forgot about super. I thought about it and then I didn't say anything. One last bit. Because the player and the room are extending container, and container has a constructor, we need to make sure that this constructor gets called, because it's important that this line of code runs when we're making a room or a player. And so different languages do this in different ways. JavaScript does it like this, which means call the constructor of the superclass. If it took any arguments, we could specify them there in the super call.
I think in the main logic, we forgot to do the add the item onto the end of 83 and 84.
Oh, you're totally right. Oops. Good catch. Let's see how that's treating us. We're outside the cave entrance. There's a sword. I don't see that here. Whoops. So that didn't work right. Oh, it's because the names changed of the... I changed the names of all the fields. So if I.name, let's see here. It's ID now. Sorry. Let's see if that makes it found. If the cache works. Ha! And now it's not there anymore. And I could hopefully drop it here. And look, and there it is. Ha ha! So that's my little introduction to text adventure games and object-oriented programming. Any questions about it all? Like I said, I'll post a link to the thing.
First of all, this is really cool. I love it. It's very neat. I'm excited to mess around with the GitHub repo. One of the things, and this is a little bit of a sidetracky bit from what you were covering, but the thing about object-oriented programming and programming in general that just does not stick in my brain is asynchronous programming. Like, so that core loop that you have outside that everything's running in.
Mm-hmm.
I don't know how that works.
Like the async await stuff. Yeah, I thought that was one of the more fun parts of this project, actually, aside from learning about how JavaScript modules worked. Yeah, if you were looking at the main loop, it has this line in it right here, which is kind of a strange line. Like, what's the await thing actually doing here? And what's readLine returning? Well, it's hopefully returning the line that I typed in and hit return on. But what happens in the meantime while it's waiting for me to actually do that? And the way it works is really weird behind the scenes. So the subject you want to look up here is JavaScript promises. That's what we're talking about. When I call readLine, readLine actually returns immediately. And it returns an object that represents a promise to do some future work, which is really weird. I'm like, hey, read a line. And it says, okay, I'm going to read a line. And here's an object that represents what's going to happen eventually when I read that line. Back to you is how it goes. But I don't, as a programmer, I don't want that to happen. I want to stop right here. Like, I want to do nothing until a line is read. And so await is a little piece of syntactic sugar to help that happen. So behind the scenes, JavaScript is like, oh, you put await here? That means that readLine must return a promise that something's going to happen in the future. And what I'm going to do, what JavaScript am going to do, is I'm going to take all the rest of this code, bundle that away to happen later, and then I'm going to go about my business and do what other JavaScripty things I have to do. And then later on, when I do finally hit return, JavaScript's like, okay, wait a second, you hit return, so that promise is fulfilled now. We've got a line, which means now it's time to execute all the rest of this code here. And so this is happening behind the scenes, but I don't need to know that as a programmer. All I need to know is that readLine returns a promise, and it's asynchronous, and I'm going to put await at the front of it so that I can, as a programmer, still just think about my code in a linear way. I don't want to have to worry about the fact that readLine doesn't happen until later. I just want to write some code and have it happen in the order that I expect. And so that's why await is useful, because it takes this thing that's asynchronous that will happen later in the future and makes it look like, from my code's perspective, it's actually just happening in order. And the reason it has to be this way is because JavaScript is single-threaded, and if we actually stopped here to wait for return, like, none of the other parts of the web page would run. JavaScript would just be like, I'm doing nothing but that. I'm waiting for this to happen. And so this allows us to give control back, so that if it's animating something else on the screen or whatever it's doing, it can do that. If you want to actually see, this is what it looks like. So here's readLine. It returns a new promise, and the promise object takes a function as a parameter, as an argument, and that function has a special form that kind of looks like this. It also gets a function passed to it, so it's a function that you pass into the constructor that gets a function passed to it once it gets called. So the whole thing is just like brain exploding.
Something you wrote, or is that?
I wrote this part, yeah.
Okay.
So the rest of this code is actually pretty straightforward. I'm like, hey, let's go get that input form. Let's focus it. I put a key press handler on it, so as I'm typing keys in there, this handler is getting called. I check to see if the key that got pressed was enter. If it was, I look at the value that's in the field, I trim the white space off, and then I say resolve command. This is where the action happens. Resolve is a function. That function got passed to me up here by JavaScript. And when I do this, that is when the await part finishes. That's when it comes back to me. I say resolve with the value that I want that promise to resolve to, and then back in the game, this resolves to a value, the command value, which I store in C right here. So the thing I returned from the thing I returned with resolve, or the thing I passed to resolve, that's what ends up getting returned by the function at the end of the day. It's all pretty wild, but as programmers, we just remember the short of it is, if you have an asynchronous function, you await it to be done. And if you don't await it, you would just get a promise object back immediately. And you're like, oh, what do I do with that? But you see right here, that's all I'm returning is a new promise object right away. So, yeah, that's my whirlwind intro. Clearly, it's not enough to go on, but we could talk about that for another
Sorry for
presentation.
making you do a second
Yeah. Kim,
I do have something.
pardon me.
Number one, it's been like a year or two since we actually discussed object-oriented programming, and so while when I write programs, I sometimes think about them that way. We've been doing a lot of like Python scripting stuff, and so it's like such a nice refresher. But how
Glad to hear it.
many years did you program before you started being like, oh, I'm just gonna pass in this function as a parameter, like willy-nilly, because I know that it works. But like, how long did it take you to start thinking about solving the problem by passing around functions like that?
A while, yeah. And I'm trying to think about when it first started. So that language I mentioned up front where all the variables were constants, that's a functional programming language. And so for that, I started getting really used to that idea of like, I'm gonna pass functions around, and chaining the functions together like this is what makes that work. So that was part of it. And when was that? That was 15 years ago or something. So I'd gone through a fair amount of my career before I started thinking about it that way. And then part of this also came naturally from doing a lot of JavaScript programming, which is what I did in my previous life. And this whole promise thing didn't used to exist. It was just callbacks all over the place. So it's still asynchronous, but you would call a function and you'd pass a function to be called once that thing completed. So start doing this long process and call this when you're done, please. And so that pattern, that JavaScript just does a whole lot of that. And so I got used to that pretty quickly in JavaScript. But then the promise thing came along because people were finding that they would have a callback that had another callback that had another callback. And JavaScript code looked awful. It was like nested forever deep in functions inside functions, and your brain just exploded looking at it. And so somebody came up with this idea of the promise thing, and they're like, hey, what if I could call a function, and then I could say dot then do a different function. And then I could say dot then do a different function. And they came up with this idea for making it more linear. Instead of nesting, now we have a bunch of things in a row. And that's how promises work to start. And after a while, people got tired of typing dot then all over the place. And they're like, wait a second, we could add this syntactic sugar with this await thing and have the dot then part be implied and have JavaScript do it automatically. And now we can just write code like we normally wrote it. And so following that path, to get back to your question, I got more and more used to passing functions to functions around. But still, even with all that, when I look at the, oops, where am I going? This is print, read line. Yeah, when I look at this stuff, it's still tough for me to follow. I'm like, okay, I'm making a new promise and I'm passing a function into that. Great. And my brain hitches a little bit because when I say read line handler right here, I'm not calling it. I'm just referring to it. So I'm like, I'm not even calling this function now. Like, who calls this function? That's already a little confusing. And then when somebody does call it, whoever does that, they're going to call it with a couple parameters. The other one's actually called reject. I'm just not using it. And these are functions. So I've got to stop and think hard about like, okay, I'm in a function that got called because I passed this function to a promise constructor. And now when this function gets called, it gets two more functions passed to it. And one of these functions, resolve, is what I'm supposed to call if things are successful. And the other, reject, is what I'm supposed to call if things are not successful. I just decided that for this one, it's always successful. So no point in rejecting ever. But then I call this, and then there's another place where my brain freaks out because when I call resolve, where does this go from here? And it goes to the dot then or to whatever we're waiting on. So that gets called. It's not easy to follow. So, my long answer to it is that, and my shorter answer is 15 years.
Great. I'll take that promise.
I don't think it takes everybody 15 years to learn this. I just think that's how long kind of my career went before I started bothering figuring it out. So, also with all things, it's how much you pour over it and practice it. Like if you sat down with this for a concentrated hour and you messed with it, the clarity of understanding would go up tremendously. And this was driven home to me just today. I was looking at Professor Donnelly's notes for algorithms, the stuff I'm going to be teaching next week. He's like, here's a simple proof by contradiction about this such and such thing about greedy algorithms. And it's probably 10 lines of proof by contradiction. And I spent a good 25 minutes on those 10 lines today figuring out what the hell it was saying. It was all correct, but it took me that long of just on my pencil and paper, one character at a time. I'm like, what does this mean? How is this working? What are we getting at? And I think that kind of concentration is useful for a lot of this programming stuff, where it seems so mysterious at first. And sometimes you just got to sit down and really pound your head against the wall until it starts making more sense. It's always possible. For almost all these computer problems, you can always do it. Like, we're all smart enough to make this happen. It's tough for virtually everybody, myself included. Anything else? Thanks for bearing with me for that half hour.
Thank you.
I had all kinds of fun writing this thing. That was a good learning experience.